Welcome to the riverbank. When we evaluate rational numbers, we follow one steady rule. Watch the direction and the size. Look at this vertical number line. The exact surface of the water is our zero. Anything above represents a positive direction, reaching up where this heron stands. Movement below represents a negative direction, tracked as the river otter dives into the depths. Treating this ecosystem as a mathematical space lets us track position and distance, the mechanics we use to correctly compare signed numbers in the real world. Let's test that out. Which is mathematically greater, -2.5 or -1.75? We have to move past the impulse to choose based on the larger digits alone. Because both of these values are negative, they exist entirely in the space below our zero line. Look at these ripples acting as tick marks along the bank. While 2.5 feels larger, rely on location. Following these tracks plots both points. -1.75 sits closer to zero. The rule is simple. The value farther right is greater. Since -1.75 is farther right, it is greater than -2.5. Mathematical position dictates value. We separate the size of the digits from where the number actually lives on the line. Let's look at this diving otter, swimming at a depth of -18 feet. What does the absolute value of -18 mean in this physical context? Absolute value measures pure physical distance from zero. It strips away the negative or positive direction. If we measure the physical distance from the animal straight back up to the water surface, we count exactly 18 feet of space. The negative sign gives us the direction, below the water, but the absolute value gives us the magnitude, meaning the actual 18 feet of physical distance traveled. We apply the same logic to other environments, like temperature. Say a city is at -4 degrees, and a mountain is at -9 degrees. Pause the video for a moment. Visualize these two temperature points on your mental number line and determine the correct mathematical comparison. Let's verify your mental image by mapping both temperatures onto our riverbank number line. Look at their locations. Because -4 sits farther to the right than -9, it represents a greater value. -4 is greater than -9. Translating real-world contexts into mathematical inequalities relies entirely on plotting their spatial relationship accurately. Across all rational numbers, the governing rule holds up. A value is greater simply because it is farther right on the number line. And we can see the difference between comparing raw value versus absolute magnitude right here. -8 is less than -3, but the absolute value of -8 is greater than the absolute value of -3. Mastering this spatial relationship provides the exact foundation you need for advanced operations with signed numbers. Keep watching the direction and the size, and the math will follow.